Okay, let's jump right into this explainer and crack open one of history's absolute coolest cold cases, the Shugborough Inscription. For literally hundreds of years, this strange carving has completely baffled historians and code breakers. But today, we're going to look at a totally groundbreaking perspective from Kevin L. Brown. He's a researcher, inventor, and author, and he approaches this whole thing not as some romantic mystery, but as a hard, data-driven puzzle. It's a real game changer.
So, here is our path for this explainer. 1. The unsolved monument mystery. 2. Brown's topographic vector hypothesis. 3. Decoding the mirror inversion. 4. Translating the map instructions. 5. Field test mechanisms. And 6. Falsification and scientific proof. We're going to turn this old myth into a structured, data-driven briefing.
All right, Section 1, the unsolved monument mystery. Let's establish the basic facts of this monument that has had people scratching their heads for generations. Picture this. You're walking through a beautiful English estate, and you stumble across this massive stone monument. It has a carved replica of a famous painting, and right beneath it, a string of what looks like completely random letters.
Check out those letters, O-U-O-S-V-A-V, and they're framed by a D and an M. Now, for centuries, people just assumed these were sentimental initials for a hidden romantic poem, or maybe a Bible verse. But here's the problem. Translation attempts are always just guesswork, right? I mean, there's absolutely no way to prove a poem is the correct answer. Without proof, it really just remains a block of carved letters sitting on a stone.
Moving on to Section 2, Brown's topographic vector hypothesis. What if this isn't a poem at all? What if we've literally been looking at it completely wrong for over 200 years? Kevin L. Brown proposes a massive shift in how we think about this. Instead of a poem, he suggests we treat these letters as a practical map overlay designed to actually navigate the physical estate. He calls it a topographic vector cipher. Now, topographic just means it relates to the physical landscape, and vector means it gives you a specific direction and an angle. So under this theory, the monument isn't just a fancy tombstone, it's literally the starting point for a map. Section 3, Decoding the Mirror-Inversion. To read this map, we have to uncover the hidden mechanism that unlocks the code. And you know what? The clue is right above the letters. The sculpture above the text is based on a famous painting by Nicolas Poussin, but there's a huge catch. The sculpture was carved as a mirror image of the original painting. Now, why would the builder go through the trouble of carving it backwards? Brown argues this definitely wasn't a mistake. It's the master key. It's an instruction telling the observer to reverse their thinking. And that brings us to the mirror inversion rule. Because the carving itself is a mirrored image, Brown mathematically reverses the alphabet to convert those letters into numeric directional values. So if A is normally the first letter, in a mirrored alphabet, A becomes 26, D becomes 23, V becomes 5, and so on. This simple flip transforms a string of meaningless letters into a sequence of highly specific numbers. It completely changes the puzzle from a language problem into a math and geometry problem.
Let's look at Section 4. Translating the map instructions. Numbers alone aren't quite enough, right? They need to tell us what to actually do on the ground.
By grouping the letters together, Brown translates them into 3 specific physical instructions. Here are the 3 example decodings directly from his research. First, we have the outer letters, DM. This translates to define the memorial frame, meaning you use the physical monument as your anchor point. Second, the first chunk of the middle letters, OUOS. This decodes to offset under the obelisk, orient south. That gives us our starting direction. And finally, VAVV. This translates to use the V-shaped alignment, or valley vector, to locate the vault marker. This tells the surveyor exactly what kind of line to project across the estate. To put it in super simple terms, this hypothesis translates a cryptic jumble of letters into highly specific, step-by-step walking directions. Just look at the quote. Apply the mirrored offset, project southward, and follow the V alignment. It is completely stripping away the idea of a romantic poem and replacing it with a clear field instruction. Start at the monument, move slightly to the south, and follow a specific angle until you hit a target. Think of it like a treasure map, but the X is found using geometry instead of a dotted line. Section 5, Field Test Mechanisms. So here is the absolute crucial point. How do we take this cool theory out of the lab and actually prove it in the real world? Because an idea is really only as good as its ability to be tested. To do this, Brown established a strict 3-stage field protocol. Here are the test mechanisms you'd actually use. Step 1 is monument orientation. You physically go to the monument and measure its exact compass angle. Step 2 is mirror numeric conversion. You do the math we just talked about, converting those letters into numbers using the mirrored alphabet. And step 3 is landscape projection. You draw those resulting angles and lines onto a map of the estate and you see where they lead. The entire goal is to see if these projected lines actually intersect a known, measurable feature on the property, like an old well, an artificial mound, or a hidden vault.
Section 6. Falsification and scientific proof.
And this is exactly what makes this a serious scientific model. It doesn't just ask us to blindly believe it, it provides the exact parameters required to prove it wrong.
This is the hallmark of real research. A true scientific hypothesis must have falsification criteria. That just means there have to be clear ways it can fail under testing. Because, if a theory explains everything, it actually explains nothing. So how do we go about breaking Kevin L. Brown's model?
Well, the research lists exactly how the hypotheses can be defeated. Here are the 3 falsification parameters. First, if historians find proof that the sculptor just made a mistake and carved the painting backwards by accident, well, the mirror will fall apart. Second, if you reverse the numbers and they just produce random, meaningless angles that don't map to a compass or geometry, the model fails. And third, and this is the big one, if the projected lines just point out to an empty patch of grass with absolutely zero historical or physical significance, the hypothesis is successfully defeated. It has to point somewhere real.
Kevin L. Brown's research ultimately offers this incredibly logical, testable lens to view a mystery that has baffled people for hundreds of years. By treating the Shugborough Inscription as a physical alignment tool rather than just a literary message, he takes the mystery completely out of the realm of myth and drops it squarely into the world of land surveying, mathematics, and geography.
All of this leaves us with one incredibly thrilling question. If this map is right, if the math actually holds up and the lines project perfectly across the English countryside, what exactly is waiting to be found at that closure point? I mean, what did they go through all of this trouble to hide? And honestly, that is exactly where the math ends and the real adventure begins.